Okay, this example is one where we can use a technique that I call factor and cancel, which is useful when you see 0 over 0 and you're able to factor something common that cancels. So as with any limit, the first thing we're going to do is plug in x equals a. And we'll just see what happens. And here we see the 0 over 0 structure. And there are a couple of techniques to handle 0 over 0. The one we're talking about today is factor and cancel. So what we're going to do is we're going to factor this function's numerator and denominator as needed, and hopefully we'll see a common factor that cancels. The numerator is a difference of squares. That factors is x minus 4 over x plus 4, or x minus 4 times x plus 4. The bottom is already fully factored. Here we see the x minus 4's cancel, and we're left with the limit as x goes to 4 of x plus 4. When using this technique after you have canceled the common factors, you reset and you try plugging in x equals a again and see what happens. In this case, we get a number, which means that we're done. That's our answer. Formally speaking, we would write, although this isn't fully necessary, we rewrite the beginning and the end, and that is our answer. Okay, this next example will work, is slightly more difficult, but not that much more difficult, and employs the same technique. We should never assume that this is going to be the 0 over 0 structure. We should confirm. So we plug in x equals a, and we just see what happens. On the top, we get 0. This is 4 plus 6 minus 10. And on the bottom, we get 4 plus 2 minus 6 is 0. We again see the 0 over 0 structure. So we will try factoring and canceling. This one's slightly more difficult because we need to factor both the numerator and the denominator. So it looks like the numerator is minus 5 plus 2. And the denominator is minus 3 plus 2. Pro tip, if you are taking a calculus class in a typical situation, if you see a 0 over 0, then you should always be able to see an x minus a factor in both the numerator and the denominator. Here a is negative 2, so we should see an x plus 2 in both the numerator and denominator. So if you're trying to factor it and you don't get that cancellation, then either it's the wrong structure or you're not factoring correctly. All right, so now we have the limit as x goes to negative 2 of x minus 5 over x minus 3. And here again, as always, we just try plugging in the a and see what happens. So we get negative 2 minus 5 over negative 2 minus 3. It's negative 7 over negative 5 is 7/5. Because that's just a number, we do in fact get equality, and that is our answer. Again, if we're writing this formally, though we don't have to, we would write the limit as x goes to negative 2 of x squared minus 3x minus 10 all over x squared minus x minus 6 is equal to 7/5.